Hello everyone, I am Dr. N. Govin, Associate Professor, Department of Mechanical Engineering, RRNJC College of Engineering, Guntur. I just want to introduce the basic concepts of carbon nanotubes. So the carbon nanotubes are allotropes of carbon. These are cylindrical carbon molecules having interesting properties that make them potentially useful in many applications in nanotechnology, electronics, optics and other fields of material science, as well as potential uses in architectural fields. They exhibit extraordinary strength and unique electrical properties and are efficient conductors of heat. Their final usage, however, may be limited by their potential toxicity. So let us see how these carbon nanotubes are generated. So using arc discharge method, laser ablation method and other methods like chemical vapor deposition, so carbon nanotubes are generated. So carbon nanotubes can be found in carbon soot of graphite electrodes during an arc discharge involving high current. This process yields carbon nanotubes with lengths up to 50 microns. Laser ablation method, another method. In this method, laser ablation process, a pulsed laser vaporizes a graphite target in a high temperature reactor while an inert gas is inserted into the reactor. Carbon nanotubes develop on the cold surfaces of the reactor as the vaporized carbon condenses. So other methods include chemical vapor deposition, natural, incidental and controlled flame environments. So there are three types of carbon nanotubes, uh, zigzag type, armchair type and chiral type. So these are distinguished by their indices, a vector having indices m and n indices. So the one n and m are different, you will get zigzag type. You will get chiral type. If n and m are equal, we will get armchair type. If n is equal to 0 and m will have a number, a constant, we get zigzag type. So the properties are strength and electrical, thermal and some defects and one-dimensional transport and toxicity. So these are the carbon properties of carbon nanotubes in various fields. Strength properties. Carbon nanotubes have the strongest tensile strength of any material known. It also has highest modulus of elasticity. So here we have different properties like Young's modulus, tensile strength and elongation at break. So the various properties are varying from one variety to another variety like armchair, zigzag and chiral type of single wall nanotubes and multi-wall nanotubes they are compared with the stainless steel Calvar and Calvar T. Electrical properties. If the nanotube structure is armchair, the electrical properties are metallic. If the nanotube structure is chiral, then the electrical properties can be either semiconducting with a very small band gap, otherwise the nanotube is a moderate semiconductor. In theory, metallic nanotubes can vary the electrical current density of 4 into 10 power 9 amperes per centimeter square, which is more than 1000 times greater than metals such as copper. Thermal properties. All nanotubes are expected to be very good thermal conductors along the tube, but good insulators laterally to the tube axis. It is predicted that carbon nanotubes will be able to transmit up to 6000 watts per meter per Kelvin at room temperature. Compare this to copper, a metal well known for its good thermal conductivity, which transmits 385 watts per meter per Kelvin. The temperature stability of carbon nanotubes is estimated to be up to 2800 degrees centigrade in vacuum and about 750 degrees centigrade in air. So some defects are appearing in the carbon nanotubes which leads to failure of the carbon nanotubes. Defects can occur in the form of atomic vacancies. High levels of such defects can lower the tensile strength by up to 85%. Because of very small structure of CNTs, the tensile strength of the tube is dependent on its weakest segment in a similar manner to a chain where the strength of the weakest link becomes the maximum strength of the chain. So it can be considered as a one-dimensional transport. Due to their nanoscale dimensions, electron transport in the carbon nanotubes will take place through the quantum effects and will only propagate along the axis of the tube. Because of this special transport property, carbon nanotubes are frequently referred to as one-dimensional. Nanotubes hold applications. Nanotubes hold the promise of creating novel devices such as carbon-based single-electron transistors that significantly is smaller than conventional transistors. Here you can see the transistor, nanotube, transistor. Nanotube is used as a transistor. Nanotubes will have excellent strength to weight ratio, creates the potential to build an elevator to space. Health hazards. According to the scientists at the National Institute of Standards and Technology, carbon nanotubes shorter than about 200 nanometers readily enter into human lung cells similar to the way asbestos does and may pose an increased risk to health. Carbon nanotubes, along with the majority of nanotechnology, are unexplored matter, and many of the possible hazards are still unknown. So, with that, the basic concepts of carbon nanotubes is completed. Thank you very much.